believed in everything, but Eng, I don't kid you. Eng says I know you changed. I never see you cause you're always busy ditching class. I really wish you had a different way of doing math.
Hey guys, it's Mr. Eng. Let's go over your Module 2 test, February 21st, 2024, version A. Complete the sentence, describe the end behavior. Okay, so this here, you could expand it, and I pull out my calculator. I'm just typing in -4 to the 7th power, gives me negative 16,384. That'd be x to the 7th. And all we need to know is that this is an odd degree, just like the easiest one, linear. And then this is a leading coefficient that's negative, so it's going to switch these. So then your graph's going to be, looks like that. Okay, so that means going towards the left. So as I go towards the left, what's happening? This is up, right? So up is A. Number 2, state the domain range of that function. So again, odd down, you can actually use the one we just have. And domain and range, domain goes left to right. Let's draw a coordinate plane here. And anytime you just have these two arrows, it's always going to be negative infinity to positive infinity. So that would be A. All real numbers is the same thing as negative infinity to positive infinity. Question number 3, use that to answer the questions. The leading coefficient is the one in front. Now the temptation is to think -2, but the answer is incorrect. You have to look for the highest degree. That is the leading coefficient because that should be -3x to the 6, and then everything else falls in line. So leading coefficient is -3. What is the value of the function when x is equal to 1? So if I replace -1 in all of that, I don't have to put it in order. Okay, so that's going to be 1 times -2. 1 to the 5th is 1 plus 9. 1 to the 6th will be 1. -3 plus 10. That one's actually to the 3rd power. 1 squared is still 1 plus 14. Minus 36 minus 12. So I got 7, 4, 14, 28. 28 minus 36 gives me -8. Minus 12 gives me -20 is my answer. Okay, number 4, we have a graph here, and it's a cubic function to the 3rd power. You'll notice every time I pick 1, x equals 1, it looks like all of them have 1, 90. So I'm going to pick 2. So this graph, that'd be 120, 2, 105, and this one is, like a 0. So let's go ahead and put in x equals 2 and see what happens to our graph. So now I'm just inputting into this function. 832, 4 times negative 48 gives me negative 192 plus 280. So 32 minus 192 plus 280, I get 120. And then 120 was this graph right here. Question number 5, given the graph, select all the intervals which the real 0, so that just means that it intersects or crosses the x-axis. So let's do this one at a time with each color. So -3 to -2. Let's make sure you can see the x, and here's the y. So this orange one, -3 to -2, -1, -2, -3. So I don't see anything between those two numbers, so not that one. Let's go between -1 and 0. -1, here's 0. It is crossing right here, so I would say D. Let's try another one. 1 and 2. So here's 1, here's 2. I see it right there. I think that one works. And then H. Trying to find a color I haven't used. 3 and 4. I don't see the graph over here, so nothing on that one. So my two answers are going to be D and F. Number 6, use a table of values. So I'm just going to graph this. Quick sketch, -1, -2, 1, 2, 3. Then I notice there's -75. So I'm going to count by 25s. Okay, let's graph this. -2, 16. -1, 6. So it's like here. Then goes back up. 1, 4. Goes back down. -2, 12. And 3, -74. So looks like a graph is doing something like this. Okay, where is the maximum? I'm going to say at that point. And so that is 1, 4. So x is 1. So this is an order pair 1, 4. That is here. And the temptation is to think the answer is the largest number at x equals -2. That would be incorrect. Number 7, which is a polynomial. Remember, the polynomial has a base that's a variable or a letter. So this is a base, that's good. And then the exponent, can't spell, is the degree. It must be a number that's whole, no fractions, and no negatives. Okay, so I have a negative here, so this is not a polynomial. This is a constant, that's okay, that doesn't matter. It's the one with the variable, so that one is a polynomial. Let's go to the back sign. Number 8. Determine the quotient. So really what this is you're going to divide this on every term. I should say y to the 5th. And we had a phrase in class, when in doubt, write it out. So that would mean something like this. Let's do this one in pink. 4 times 4, x squared times, I don't know, x to the 6 would save me some time. Y to the 5th, y to the 5th. Remember, when you have the same base, you can add the exponents. Add the exponents. You can cancel your 1's, x squareds, y to the 5th. So your answer is just this, 4x to the 6, y to the 5th. Let me do that a little bit more spelled out on this next one. 4 times negative 9 times x, and then lots of y's. 5, 6, 7, 8. All over 4 times xx, y. So you can just go through and cancel. 4 divided by 4 is 1. Those are 1. So then you're left with negative 9 x squared y to the 3rd. And one other way to show you guys this one. 12 divided by 4. X to the 2nd, x to the 2nd, y to the 5th, y to the 5th. This would be, you can do something like 3 times 4, and 4 is 2 to the 2nd power. This one is also 2 to the 2nd power, so you can have 3 to the 2, pay attention, this is new, I haven't taught you this, but 2 minus 2. Same thing with the x squareds. It's the 2 minus the 2. 2 minus the 2. Y to the 5th minus the 5. So pretend it's a big subtraction sign, and then you would just get 2 to the 0. Well, anything to the 0 power is equal to 1. Anything to the 0 power. So that would just all represent 3, and it's positive. So this one, BC. Orange, be here, and then the green one would just be 3. Okay, number 9, we are going to add this one together, and you could just put them underneath, right? Because you are adding plus 6x to the 3rd plus 8x squared minus 15x minus 4. We are stacking them. And so I'm just looking at the numbers in front. 7 minus 19 is negative 12. 9 plus 6 is 15. The degree or exponent stays the same. Negative 10x squared minus 3x minus 15 is our answer. Let's box that. Miko is creating a basic design for a new box to ship out products for a toy company as shown in this image. Find an expression that can be used to represent the volume. Remember, the volume is length times width times height. You're just multiplying all these. So it doesn't matter, you call this one height, length, and width. You're just multiplying all those. I'm going to multiply 3x plus 8 and 2x minus 7. I'm going to use a box. We're going to multiply first. 6x squared, 16x, negative 21x, negative 56. So I have 6x squared. You're adding now, minus 5x minus 56. So I just multiplied these two, and now I'm going to multiply by the x. So I'm going to distribute to each of these terms. So that becomes 6x to the third minus 5x squared minus 56x. And this would be the expression for my volume. Okay, you can do this in any way that you want. I'll pound through both of these. Let's do long. Okay, x is going to go to 12x to the third. The answer is 12x squared. So I'm now going to multiply here. 12x cubed plus 84x squared. 12 minus 12 is 0. 103 minus 84 gives you 19x squared. Okay, 19x squared divided by x is just going to give you 19x. So, forgot to bring that down. Let's distribute again. So 19x squared plus 133x, and now we need to subtract. 19 minus 19 is 0. 115 minus 133, negative 18x. Bring that down. And then x goes into negative 18x. Negative 18. Now we distribute. Negative 18x. Negative 18x times 7 is negative 126. So we're going to subtract these, and they'll equal 0. Okay, so determine the quotient. The quotient is what's on top. So 12. Write the dividend. That's what's inside in pink. Just recopying it. Is equal to the divisor, which on the outside, the product is multiplication. I have a quotient here. And no remainder. Okay, so if we were doing that with synthetic division, you'll set this equal to 0. You'll get x equals negative 7. Then I'm writing the coefficients. 12, 103, 115, negative 126. Bring down. Multiply, get negative 84. Double check that you'll get 19. Multiply those two numbers, you will get 133. Subtract, you will get negative 18. Then multiply, you'll get 126. And so you'll see that those numbers, 12, 19, negative 18, represent the coefficients of those numbers. So that would just, if you had to write it out, add an x now, add another x to the previous term, so that would become 12x squared. And that represents what you write there. Okay? All right, last one. Pascal's triangle. This is a 5th degree, nth degree. My coefficients are 1, 5, 10, 10, 5, and 1. This is my A term. I'm going to count down. The number goes from the outside of the parentheses. 2m to the 4th, 2m to the 3rd, 2m squared, 2m to the 1st, and 2m to the 0. B is negative 4k, and we're going to count up starting at 0. And getting really sloppy, just gotta fit it in there. Key is that degree is on the outside. Okay, so anything to the 0 power that just equals 1. 2 to the 5th power is 32. So my answer is going to be 32 m to the 5th power. Okay, so your k will stay, m to the 4th power, and then I'm multiplying 2 to the 4th. 2 to the 4th is 16 times that 5 times the negative 4. Negative 320. Okay, this one's a little bit trickier. I'm going to go right to left. Negative 4 times negative 4, 16. 16 times 2 to the 3rd power would be 8 times 16, and then times 10 would give me 1280. M to the 3rd, k squared. Okay, over here, parentheses, negative 4, close your parentheses to the 3rd power, times 2 squared, which is 4, and then multiply that by 10. Negative 2560 m squared, k to the 3rd. Okay, negative 4 to the 4th power times 2 times 5, 2560 m to the 1st, k to the 4th. Alright, anything to the 0 power is 1, so I just have parentheses, negative 4, close the parentheses, to the 5th power. Negative 1024, k to the 5th. And the bottom one would be our answer. Hopefully that was helpful. See you guys.